Hello guys, so welcome to this small series of tutorial, and this series about how to make a Maya node running assembly code, right? So basically I wrote a Maya plugin, a push deformer, so nothing crazy, fairly simple, but rather than use the Maya API and regular C++, the core body, so the actual algorithm of the deformer is written in assembly. You can actually see here that's part of the code we're going to check, right? I'm going to explain how I did it. But before getting anywhere near that, let's address the elephant in the room, right? So before you jump on me, screaming at me like that's useless, why did you do that? Let me tell you firsthand, yes, production wise, that's useless. That's not something I will ever do in a production environment, right? Also because my ego is not big enough to think I can do better of the compiler, right? The guys that write the compiler are much better than me in doing optimization, and we will see later also why. There are optimization that I cannot do in code because otherwise the code becomes unreadable, right? And that also boils down to when the compiler see handwritten assembly, it doesn't touch it whatsoever. It just grabs it, convert to instruction, that's it. No optimization, nothing, right? As it happened in C++, right? So that's not the point, not getting faster. Actually, I was able to go slightly faster, but just because my code was using AVX in assembly and the other code wasn't. If I was going to use intrinsic or extrinsic, I never know, from Intel, probably the code was going to be faster than mine. So really no point in doing that. So why did I do it? Well, it's just a learning experience, right? It's good to know some assembly to be able to debug it, right? To read it can help to figure out what's going wrong in your code. You understand better uh, what your code is doing. It's also helpful for optimization, right? So you actually can see if your whatever you're writing a class, a vector class, you want to access a value, you can figure out from the assembly, if that boils down to a function call or the compiler can successfully optimize that, and all these kind of things. So there are many reasons to when we will want to know some assembly, right? So that's the main reason behind it. And the only reason why I did it in Maya it's just because it has some more meaning. Basically, I can do some more juicy example and tests, right? Rather than going to, oh, okay, let's do our console application, let's do some operation. That's too simple, right? I wanted some real test case, right? So I just grabbed a plugin I wrote and converted to assembly, right? So also there was some extra thing I could do that it's nice for using AVX or even trying to thread, right? Because though you can process one vertex per thread and stuff like that. So now that we did that, let's quickly cover let's go over what we're going to cover, right? So what we're going to cover in the next series of videos is the following. First, we will start showing what's the basic algorithm, right? Then we're going to do the most basic assembly implementation. Then we're gonna move it a step above that and trying to use AVX, right? Once we have that, there's a small experiment where basically I try, you can see in this file, to split the loop and process multiple item in the loop to try to reduce the jump instruction, and we will discuss about that. And finally, I went overboard and tried to do assembly using threading. So my actual deformer is running multi-threading, so handling manually all the feeding the threads, kicking the threads, all these kind of things, right? And we will talk about that later. We will discuss the results and all these kind of things, okay? So that was just the basic introduction to what we're going to do, and the next days I'm going to post the rest of the series. Meanwhile, I work on them, right? So stay tuned, share it around, and see you in the next video, guys.